Hi, welcome to video 10.4C, even more polar graphs. Okay, so I want to talk about this symmetry thing once again. Because the cosine of theta equals to the cosine of negative theta, you'll have symmetry with respect to the horizontal axis. Because the sine of negative theta equals negative sine of theta, you're going to have symmetry with respect to the vertical axis. So both of these are going to be circles. R equals A cosine theta, R equals A sine theta. The center will be at A over 2 comma 0, whereas here the center will be at A over 2 comma pi over 2. The key thing is that this circle, because of the cosine, is going to be symmetric with respect to the horizontal axis. So it's tangent to the other axis. So it's symmetric with respect to the horizontal axis, tangent to the vertical axis, same thing, it could be on the other side. When it's sine, it's going to be symmetric with respect to the vertical axis. The vertical axis will split the circle in half, and the circle will be tangent to the horizontal axis. Okay? And again, you just need one point, and you'll find out very quickly whether it's on the right or the left, or above or below. Okay, so those are circles. So here's some examples. R equals 4 cosine theta, center 2, which is half of that, 0, radius 2. Tangent to the vertical axis because it's symmetric with respect to the polar axis because it's cosine. Here, circle half of this, which is negative 2 comma pi over 2. So if you go 2 to the left and then pi over 2, you're here. The radius will be 2, and it's going to be symmetric with respect to the vertical axis and tangent to the horizontal axis. Okay, limacons now. We had a little peek at those before. Limacons have this basic look. R equals A plus or minus cos theta, or R equals A plus or minus sine theta. And again, you know if cos theta, it's going to be symmetric with respect to the horizontal axis, with sine symmetric with respect to the vertical axis. And right now we're going to pretend that A and B are both positive. Okay, so if it is cosine, there are 4 possibilities, okay? First of all, it's cosine. Notice they're all symmetric with respect to the horizontal axis. And we're assuming that here that B is positive and A is positive. So you'll either have what's called a limacon with a loop, a cardioid, which kind of looks like a heart, I'm not quite convinced, a limacon with a dent or dimple, and then a convex limacon. So this looks like kind of a lima bean, okay? Which one you will get will depend on the ratio of A and B, and again we're supposing A and B are both positive. If A over B is less than 1, you'll get a limacon with a loop, which you'll notice has 5 intercepts. There's 3 points on the horizontal axis, 2 on the vertical axis. If A over B equals 1, you get a cardioid. Now there's only 4 intercepts. From here on in, there's only 4 intercepts, but one of the 4 intercepts is the pole. Limacon with a dent and convex limacon, you'll notice the pole is not on the graph, and it's going to have a dent if A over B is between 1 and 2, and it'll be convex if A over B is greater than or equal to 2. Now personally, I've never memorized these first 2, because what we're going to do is we're going to make a table, check for the pole, and you'll find out whether you have 5, which includes the pole, or 4, which includes the pole. The problem will be if it's one of these, you won't know whether it has a dimple in it or not unless you know these relationships, but I wouldn't bother with the first 2. So as I said, we're going to make a table. We're going to plug in the thetas, which is the second column, and this is what we're going to do. We're going to evaluate R, but it's good to have them in that order, R comma theta. And we're always going to pick 0, pi over 2, pi 3, pi over 2, because that'll give us the intercepts. If you do not get 0 here, if you don't get the pole here, then you'll have to do a separate check for the pole. You'll take your equation, replace R by 0, and try and solve. Okay? So, first of all, you'll notice on this one that it was kind of pointing towards the right. Where the point is to the right. That's because B is positive. If B is negative, it's going to point to the left. Okay? If it's sine, it's going to be symmetric with respect to the vertical axis. If B is positive, it's going to point upwards. So if you look at the cardioid, notice how the point is pointing upwards. And if B is negative, it'll point downwards. Easiest way to graph is make a table, plug in theta values of 0, pi over 2, pi 3, pi over 2. Check for the pole by setting R equals 0 if you don't get it in the table, and then trying to solve for theta. Okay? And here's if B is negative, it's going to point down for the sine one.